Okay, so today we're doing a review of yesterday because yesterday had a lot of things about logs. When you came into yesterday, all you were really supposed to know is that exponentials are related to logs, and you can take exponentials like this and write logs. Would you please just jog your memory with that? Write a log that goes with this. I often call this a rewrite. You're rewriting this equation as a log. So thing number one, you need to know that it's related to exponentials. Thing number two, you need to successfully be able to rewrite log base 5 of 8 equals x. Thing number three, I need you to be able to put that in a calculator because not all of these work out nice. Some do, but if they need to go in a calculator, grab your calculator, please. You'll need it for today's homework. If you need to borrow one, please come on up and ask. I think your hour's been pretty good about having them. Log 8 divided by log 5. And that gives you a decimal. What did you get, sir? 1.29. If your life depended on this, I would check it. If you put 5 to the 1.29, I bet it comes out to about 8. Why not exactly 8? Because we rounded it. Okay. That's the basics of logs. Then we moved into weirder log problems that were like this. Log base 9 of 3. And you were somehow supposed to know what the answer to that was without a calculator. I know you could type it in, but there are going to be problems that use variables, and you wouldn't be able to type it in the calculator. So don't trust that your calculator would save you. We might not even allow calculators on the test. All right. Who in here was thinking, man, I wish that was a 9? That's what you should be thinking, because then the bases would be the same. Do you remember that deal? Okay, so then if that was a 9, it would have to be a 9 to the what to make it be a 3? 9 to the what? 9 to the 1/2 would be the same as 3. That means the square root of 9. Now that I've got them to have the same base, what is the answer, Mr. S? 1/2. Now let me make sure you really get that, because kids today, we'd have something like this. And they got so confused. Didn't we just establish that that right there is equal to a 1/2? It's the same exact thing as a 1/2. So then I can go 2 times a 1/2. What is 2 times a 1/2? 1. And then 1 times n makes n, so n equals 14. You got to be able to see a log in the middle of another problem and go, oh, this can be simplified to just 1/2. So this is 2 times a 1/2 times n equals 14. So you can take the whole log out of it if you can simplify it. All right, let me give you another one like that. 6 times log base 2 of 8 times n is equal to 36. I hope you're thinking about that 8 and saying, I really want that to be a 2. But it can't just be 2, because 2 isn't 8. But I could make it a 2 to the what? 2 to the 3rd. And then this whole thing simplifies to what? 3. So 6 times 3 is 18. See what I did there? I took the 6, I times it by that's just 3, and I made 18. Now it's a super simple equation. Divide by 18, you're done. That makes sense? Yes? You could have gotten rid of the 6 first, but eventually you're going to need to simplify this. So my advice is try to simplify the most complicated part first. Get the most complicated part simplified first. All right, I'm going to give you one more like that. 7 over 7 to the log base 7 of 14 times n is equal to 28. What's the whole point of today? Simplifying logs down. Do you remember this one? Bases are the same. So the answer's already there. So what's the answer? That's 14. All of that is just 14. Get used to looking for the bases are the same. Because if the bases are the same, the answer's already there. So that simplifies to 14. So now it's 7 over 14 times n equals 28. And do you get 7 over 14? Just simplifies to 1/2. So we times both sides by 2 when you're done. Poof. N equals 56. But what was the hard part? This part. What was hard about that? Knowing that if these two are the same, that's what it simplifies to. It simplifies to 14. And then that 14 can be put in instead of all that complicated log stuff. All right. I think you got the idea there. I'm not positive, but let's see if you can do it when it's a fraction. Say that was in the middle of a problem. It would simplify to what? 2, 4, 1/2. Well, you gotta tell your brain what you want, what you really, really want. I really, really want that to be a 1/2. And then you take the 1/2 and you go, what could I do to make that into a 4? How about squaring it? I mean, it can be closer to being a 4? Yes, you don't have to get it all done. You just got to go, okay, squared, ooh, it's really close. 1/2 squared is 1/4. Oh yeah, I just got to flip it over, so I make it -2. There you go. And now, this whole thing could be substituted out and you'd put in -2. So if this was in the middle of a problem that was like this, 7 times that, or how about this? We'll just make it even simpler. N times that is equal to 12. You go, oh, this whole thing is just -2. So it's n times -2. I'll make it -2n is equal to 12, and anybody can solve that. You divide by -2 and you're done. Okay. So today is all about simplifying logs, and we got a little taste of that yesterday. But there was a whole bunch of strange ones, like you won the argument. Do you remember that one? If you put a 1 in the argument spot, you get nothing. And I have a dumb saying about that. If you won the argument, you get nothing. Log base 2 of 1 is nothing. Why? Because 2 to the 0 is 1. That's equal to 0. So wherever you see something with a 1 in the argument, that whole thing is 0. Okay, so let's see if you got that. N plus log base 3 of 1 is equal to 7. Solve for n. Didn't I just get done saying that if you won the argument, you get 0? Nothing? So that's n plus 0 is 7, so n equals 7. Raise your hand if you had that. Okay, awesome. All right. The hardest thing from yesterday was probably the graphing. I'm going to give you an easy one first. Log base 8 of x. First off, you got to kind of know what logs look like. I said they were like a tree that's been blown over in the wind. Okay, that's generally how they look. And don't forget that there's an asymptote here. Why? Because you can't cross over in the negatives. Why? Because you can't put negative numbers here. Remember me saying you had to have positive numbers there? That's why you can't go into the negative territory. You can't even be 0. Why? Because you can't put 0 in the argument spot. So that's why there's an asymptote. That's how they generally look. Would you please find me 3 points, not just randomly. Like if you try to put in like 7, you'll be disappointed. That's going to be really hard to do. Log base 8 of 7. Don't do that. Pick numbers that work nice. Who can tell me 3 numbers that work nice? Let's just start with 1. Dice of Destiny. What's 1 number that would work nice? Row 5, person 4. Wait, this is row 5. And person 4. That's you. Give me a number that'd work nice here. That would work, but it would not be nice. Because log base 8 of a half is not easy. This is why we're talking about it, because I knew that some people wouldn't know. How about this? I just said when about the argument. We won the argument. Aha! You won the argument. So x is 1, and what is it equal to? Y equals, what's this simplify to? 0. 1, 0 is on my graph. Does it look like it's on my graph? It looks like it's on my graph. AS in the back row. What's another thing besides 1 that would be nice to have right here? I like it. Why is 8 a good call? Because log base 8 of 8 is 1. Because if this was an 8 right here, it would really be an 8 to the 1, right? And the bases are the same, so the answer would be 1. Okay, so 8 works. 1 works. What's another thing that would be smart to put there? Yes. 1/8. I like it. Some people are not going to know why you would go with a fraction. But if you try it, you'll like it. Because isn't that the same as 8 to the negative 1? And therefore, when you put in 1/8, it's like you put in 8 to the negative 1. And why is that good? Because now the answer is what? Negative 1. One more. It's all about that base. Megan Trainor would be so proud right now. You can either make it 8, you can make it 1/8, you can make it 1, or you can make it the base squared, which would be what? 64. Why would I want to put in 64? Because if I put in 64 where the x was, that's like putting in an 8 squared, right? And that's like, base is the same, so the answer's 2. 64 comma 2. Now the only problem with that is it's going to go off of most like pieces of graph paper, right? So that's the only problem with that, is it gets pretty big. Now somebody actually started with 1/2. And I kind of poo-pooed it, but it actually could work. It's just not easy. If you wanted to put in 1/2, you could. So I'm going to put in a 1/2. I'll squeeze it in right here. If I put in 1/2, I'd have to write this as an 8 to a power. Isn't 1/2 the same as 8 to the 1/3? But wait, that would give me 2, so I'm really close. So what do you think? Negative. So when I put in 1/2, I got negative 1/3. There's 1, 2, 3, 4, 5 points. Do I even have to have 5 points on the test? No. You have to go for 4, but if 4 won't fit, then I'd even accept 3. So if the graph will hold them, you got to give me 4 points. 5 is even better than 4, but all right. So then here's the trickiest of all then. What if it's a graph but it's not easy? What if it's this? I know some of you are like, okay, so it's a vertical reflection. No, it's actually, that's true, but that's not how you want to do this. You want to still do this with points. Because otherwise you've got to find 4 parent points, which is hard enough in the first place. And then you'd have to reflect them all. You'd have to stretch this thing horizontally. Actually, it's a shrink horizontally. And then you'd have to move it to the right. Oh, that would be almost impossible. But it's also not so easy to just throw numbers in here. Watch what happens when I put in a 1. I get 3 minus 5 is negative 2. That's not even legal. Because now I have log base 10 of a negative number. So that failed. So 1 didn't even work. So instead of just randomly putting in numbers, you got to think about what you'd really, really want. Do you get it'd be nice if that was a 10? Because it'd be log base 10 of 10. So what could we do to make it be 10? Yes? How did you do it, though? Like, what did you do in your head to figure out what number to put in? 3 times x minus 5 needed to equal 10. And you thought of, if I put in a 5 there, it would work. That's the guess and check way, but there's nothing wrong with that. But you can have a system where you just take what's in here and you set it equal to what you really want it to be, and that's an equation, and you all know how to solve equations. That's one of the things I get like amazed by on the ACT is that people think of the ACT as word problems that are really hard. All you got to do is make the word problems into equations, and most kids know how to solve equations. So if you can take your word problems, make them into equations, then you solve the equations. It's not that bad. So then what's the answer? X equals 5. So that means I put in 5, and what do I get? Well, you know you're going to get a 10. We were doing all of that because we wanted it to be 10. What is negative log base 10 of 10? What is all of this? What does this simplify to? Negative 1. So 5, negative 1 is one of your points. All right, what is something else that would be smart besides 10? What else would be a smart thing to find if this was what? 1. Everybody figure out what x should be. It's not 1. Figure out what x would need to be to make that come out to 1. That'll give you a point. This is really important. I'm going to make sure you try this right now. Everybody, try to figure out what makes this equal 1 so that then you'll get a 0, because a 1 in the argument is super simple. It just comes out to 0. It's going to be a fraction if you're doing it right. What is the equation that I should write to find this magical number for x? Row 6, first person. And what the equation is? 3x minus 5 is equal to 1. And then what would you do? Add 5. Oh my gosh, it's not a fraction. We got lucky. So what's x equal to? Sorry about that. It's just x equals 2. Thought for sure is going to be a fraction because it's not that many numbers that would have gotten lucky and get a whole number. Okay, so 2 is the x. And is the answer 1? No, this comes out to 1. See, we go back to the original. Now we know 2 is what we put in. So now I'm going to put in 2. Watch what happens when I put in 2. 3 times 2 is 6. 6 minus 5 is 1. Ooh, there's a 1 in the argument. So what does that mean? It's equal to 0. How about negative 0? Isn't that still 0? So it's 0. Raise your hand if you had 2 comma 0. Awesome. That's the hardest kind. All right. So I've already been talking to you about the new stuff for today. The new stuff for today looks just like this. You got it like an equation. Some of them are even easier than this, but this is like the hard ones. Let's say you have log base 3 of 3 over 7 times n is equal to 10. And you have to be good at simplifying logs. So you look at that log base 3 of 3 and go, ha, that's just, what is it? It's just 1. So then if that's 1, then this is just 1/7 n equals 10, and now it's super simple. Just get good at simplifying those logs. All right? Times it by 7 on both sides, n equals 70. What was the key? Figuring out what that was. That was a pretty easy one though, right? Log base 3 of 3. What if I just said log base 3 of 8? You could still make it have a base 3? No, wait, dang it. No, 3 does not work well with 8. Sorry. How about 27? There we go. Do you get 27? Could be 3 to the 3rd. What if this had been a 1/3? Well, then it's like 3 to the negative 1. And so then this is negative 1. And it'd be negative 1/7. Negative n equals 70. N equals negative 70. Okay. Now, here's the simpler ones, but they look different. So I don't know. It might be hard for you, but I don't think it should be. Log base 3 of x equals 2. Solve for x. The number one thing that I said on the first day was you got to know how to rewrite. That'll be the most important skill of the test. You'll probably have to rewrite at least on 3 of the problems on the test. I'm thinking maybe 4 or 5 of them. There'll be a rewrite involved. What's the rewrite? 3 to the 2 equals x. And if you can't solve it from there, there's not much I can do to help you. X is alone. Answer's 9. Okay. What if the x is down here? This is going to freak some of you out. X to the 4th equals 1. What does x have to be? Wouldn't 1 to the 4th? How about this? Couldn't I put it to the 1/4 power? See what I did there? 1 to the 1/4 is the 4th root of 1, which is 1. So why would the kid get it marked wrong? Remember? It's not an absolute value, but that's a good guess, but that wasn't it. I know what you're talking about. You're thinking it's plus and minus 1. That just makes it worse. Because I know, we did the 4th root, and then there's plus and a minus, but the problem is, none of them work. Remember how you're supposed to put them back in, see if they work? Watch. Put a 1 right there. Is log base 1 of 1 equal to 4? No, that's not true. So I know, it's frustrating. You did everything right, and yet the answer's not working. The fundamental problem is, you got to check your answer and make sure it works. Somebody was saying, what if the negative 1? Okay, negative 1 still doesn't work. Can't have negative numbers down there. So the negative 1 or the 1, both of them are out. Those are called extraneous answers. They're answers that seem like they work, but they don't really work. Did I tell you about my friend who played poker with an extraneous finger? Okay, so we play poker, have his hand over the table. He'd be playing with his 6th finger. Bang, 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 bang. It didn't really work. The finger was not functional. But he had a 6th finger growing out right here. Yes, I think it's called polydactylism. All right, and about 1 in every, I think it's like 10,000 babies are born with a 6th finger on their hand. And in the United States, they just surgically take it off right away because everybody's like a little freaked out. And would you tell your kid later that you were the 6th-fingered baby? So if you want to know if you were, look for a little scar right here or here. And I've only had 1 kid, but that mathematically is right. I've taught about 10,000 kids. I've only had 1 kid find an unexplained scar on their hand. it is extremely distracting. So you cannot concentrate when somebody is playing with their sixth finger that's like dangling from their hand. So I don't know. I still think about it now. Like, it's distracting me now. And you can imagine how it's probably a really good poker tactic to like dangle your not working finger in front of people. They're like, I can't think. I fold. So anyway. Okay, so S is an extraneous answer. It's an answer, but it doesn't really work. And my friend had an extraneous finger. All right. Let's go to the worksheet. I'm going to pause for a second while we pull that up. Okay. I know it's always a hot topic to know which ones you can skip, and I get it, because you don't want to waste time on ones that I'm going to say you can skip. So, for today, it's just going to be these three. I think I can do 4. 1, 2, 3, 4. This is always a trust walk. The reason I'm doing this is because it's supposed to encourage people to be willing to always do your homework, because it's small and doable. And that's supposed to mean that I'll get better performance on average. And the ideal world is this, as long as those of you that need the extra practice would actually do it. You need to be mature enough that if you guys go check this thing and you're like getting them all wrong, you should go back and try the ones I had you skip as an extra practice. Okay, so it'll work out great, because most of you guys will be fine with a few less problems. Those that needed them have to be mature enough to do them themselves. Okay, so let's start this thing. Number 1. Rewrite x to the second equals 36. And this is a smart kid trap. And I was the smart kid first hour. Guess what I did wrong. You remember? Absolute value. But wait, that wouldn't have been very smart. It was smart to catch that there was supposed to be an absolute value. What makes it a smart kid trap is only a smart kid would know that -6 is also an answer, but it's a trap. You get what I'm saying? This kid who isn't that smart never even notices that -6 was actually also an answer. But then you have to be an extra smart kid to go, but wait, you can't put a -6 there because the base can't be negative. So the smart kid goes further than everybody else, thinks, yay, I caught that one, and I've got 2 answers. And no, you're going to get it marked wrong. And the kid that wasn't that smart will get it right. Smart kid trap. That one's extraneous. So yeah, -6 was an answer, but it doesn't actually work. Why? Because you're not allowed to have negative numbers in the base. So that number seemed like it would work, but upon further inspection, you put it back in, it does not work. So you cross it off, and ideally you'd label it with EXT. I can live without that, but that's the professional way to do it. You have found the solution that is extraneous. Okay, look at number 2. X to the -1 equals 15. Don't overthink this. Put it to the right power and you'll be done. What power do you think I should put it to make that -1 turn into a regular 1? -1. Very good. And what is 15 to the -1? 1/15. Why'd I do that? Because that equals 1, and x to the 1 is the same as x, right? Okay, rewrite this next one. 125 to the x is equal to 5. And then you could go, I really, really want this to be a 5. But 125 and 5 aren't the same thing, but I could put in a 5 to the third. Because 5 to the third is 125. Now they've got the same base. And so now I'm going to put a 1 on this, because if he doesn't have a power, of course there's a 1 there. It does have a power of 1. 3x equals 1, so x equals 1/3. I'm starting to get a little nervous, like I might not be getting this right. So I'm going to put a 1/3 in there just to see if that would make sense. And then I go 125 to the 1/3 should be 5. I checked it. It works. Sweet. Okay, this one. The challenge is make that into 9 to the something. That's not fun. But here's my hint for you. First make this into a 3 to the something, because couldn't you then make it into a 9 pretty easily? So this will be log base 9 of 3 to the something, and then you can square that and it'll become a 9. Another way to say it is, what do you really want this to be? I really want this to be a 9. 9 to what power, though? It's all about figuring out what power that is. My first suggestion is, first, make it into a 3 by using square root. Then you can build it back up to a 27, and then you can flip it. Tricky one, have to say. That's probably the toughest one on the whole sheet. Okay, now you got a bunch of time to work. Please feel free to come up and ask me questions. I got a hand here already. Yes? Yes, but the problem is this. You're not allowed to change this base to something else. It won't work. I know, you're right. You could make them both have a base of 3. Now, if you wanted to rewrite it first, then you could do what you just said. So here's essentially what he said. I'm going to do the rewrite first, okay? If we rewrite it first, it'd be 9 to the 5x is equal to 1 over 27. Then we could do that thing where both of them could be rewritten as a base of 3. That might be the easier way to go. All right, I'm going to give you one more help because I got, like, most kids got along fine until they hit, like, problem 15 or 14. So let me help you with number 15. Everybody look at number 15. Here's the kind I was doing early in the hour where I was going, just replace this with a number and then solve. The blue thing I just circled, what's that really equal to? If you rewrite the 125 as a 5 to the 3rd, then what's that really equal to? 3. That's equal to 3. I know it's, but Mr. Server, you told us to write it like this. Yeah, but the reason we write it like that is because then it's equal to 3. If the bases are the same, then it's equal to the exponent. So you can replace that whole thing with a 3. So now that it's a 3, it's 6 times 3 is 18 plus 5, and then it's just a simple little equation. Okay, now I'm really done. That's all I got for the video for today.